The mole is particularly useful when balancing chemical equations. In this screencast, we'll ask ourselves, why do we need to balance chemical equations in the first place? And once we do, and once we apply molar masses, how does the mole quickly provide the amounts of reactions to mix in a chemical reaction? This is screencast 9.2. Okay, let us do an example. We're going to burn some butane. That's that pressurized liquid, it's gas at room temperature, that exists in a lot of lighters. And here's the chemical structure of butane. Notice that it's C4H10. All saturated linear hydrocarbons have twice as many hydrogens as carbons plus 2 more. 2 for each one, and then notice the extra 2 for the ends. Therefore C4H10. If it's burning, it combines with oxygen, and you may know by now that this always forms carbon dioxide and water. But in what ratio? If you balance this out, and this is one of those double everything ones, you'll see that the ratio is 2 to 13 to 8 to 10. So I went ahead and drew 2 molecules of butane, see them there, 1, 2, 13 molecules of water, 3, 6, 9, 12, 13, and watch as they recombine when they react. Nothing is wasted, and we form exactly 8 molecules of water and 8 molecules of carbon dioxide and 10 molecules of water. So these are the exact amounts they react in. So it's useful. A more useful thing, and this doesn't show up on the slide, but you might want to take a couple notes in here, is that if you wanted to actually do this, it would tell you how much to use. I know that 58 grams of butane is a mole. How do I know that? Carbon has a molar mass of 12, hydrogen 1. I'm rounding slightly. 48 plus 10 is 58. So if I did this as written on a 2 mole scale with respect to butane, I'd simply mix 58 grams of butane, 13 times 16, which I have no idea what that is, but 13 times 32, since it's diatomic, grams of oxygen, 8 times 44 grams of carbon dioxide would be produced, that's a lot, and 10 times 18, hydrogen is 1, oxygen is 16, or 180 grams of water. So if you just wrote below 58 times 2, 32 times 13, 44 times 8, 10 times 18, that would show you very quickly the perfect recipe to mix these in and exactly how many grams of each one you'd make. The mole is a very handy device for these sorts of coming up with amounts for your chemical reactions. This is screencast 9.2.